a while back, there was a project where this thought process of campus as a living lab was developed, and they ended up writing a manual out of it. Um, let me see. Okay, so we did in advance. There we go. So Campus as a Living Lab was published back in 2013, and Brian Lovell developed it in conjunction with Todd Cohen, and it was published through the American Association of Community Colleges. And I thought DOE had their hand on funding it, but maybe not. It was through the Seed Center. Um, it cites 8 common elements to effective living laboratories on college campuses, and it's I don't know, I think like 25 pages or so. So it's not a long document, and it's available. I'm working with Kim Gonzalez. We're going to get it posted so that everybody can grab a copy of it if they want to. If not, just email me. I can send you a copy of it. So campus as a living lab. I got to move something off my screen here. It's kind of getting in my way. Um, it tries to engage the right campus participants. And what that means is you have these students, an instructor, they want to work with the building for their students to learn from. That means we have to get Raf and Chris on board with us to work with us and other people in buildings and operations to give us access and be willing to take time to work with us on the different parts of the building to help for the students to see projects that they can help to influence and possibly be directly involved with. So it's really important that we engage as many of the correct people on campus as possible when we do this. Now, when you're first looking at this, you want to identify key collegiate programs. Well, I had a program that I'm teaching, and I want to just get involved with using the campus to teach the students, because there's working in the lab is one thing. You can see something that's been worked on and beat on by students for years and years and years. That's different than a boiler plant or an air handler that's been operating in a building for years and years. It's beat up in a little bit different way. And it also is different from the perspective that in the lab, the instructor has control over most of the aspects of it. But outside the lab, in the building, the instructor has no control for the most part. And it's more like a technician gets sent into a project, into a client's building to go and take a look at something and understand it, figure out why it's not working the way it should, or if it's working correctly, and have steps thought out about how to correct the situation, test it out, and possibly implement something to get it completed. It's a much more thorough, thought-provoking process than if it's done in the lab, simply because now we have this outside entity, in this case, the campus operations department for the most part, that's working with us and putting that extra added pressure of their client into the situation. The only way for a college instructor in class to get in here is to start over time building credibilities. And I've been working on this in my college now for almost 14 years to build that credibility. I've had some issues with this simply because there's been a built-in institutional thought process that you keep operations facilities separate from academic. You don't ever mix those two. It's like oil and water. It doesn't work. And so trying to fight that has been quite the battle. And in fact, I was yelled at by a campus president one time saying that, you can't be going in there and telling them how to do their job. I'm like, I didn't go in there and tell them how to do their job. I asked them to work with me to see if we can share resources and help them with figuring out things that they don't have time to work on. That's that kind of way I approached it, you know. But anyway, so it took time. I've gone through half a dozen different facility managers over that 14 years, and that's created some issues. But we're in a good place now where I think that even if I lose a facility manager, I have enough connections and cred within the organization to keep going with this. You have one of the hardest parts about doing this is integrating into the curriculum because it changes all the time. I mean, you can't go in and do the same project on a hot water boiler system every time. You want to make some impact. In order to do that, you got to keep looking at other things over time to make it effective for you and for your campus and operations and towards the bottom line, which is, from my perspective, driving down energy consumption. This also means building up some partnerships within the industry, and most college programs have these partnerships already built up, and they just need to work with how that fits into working with their operations departments. And the other thing is open labs to the community. Well, I don't know that we're going to get to the point that we actually open up our campus facilities, you know, behind the door in mechanical room stuff to the community, but we certainly can open up the lab portion of what we have to the communities. So these basic concepts that they develop for living labs is something that I think, and I have this cafeteria style approach to it where I take what I want to take to make it effective. And every entity that wants to grab on and utilize this can do the same thing. And I think, Chris, you're going to be a prime example of that. How can you use that with what you do day in, day out? So the pedagogical rationale for living labs, derivative of problem, project-based learning. So everything that we take on is project-based. Some of it's going to be problem-based, but a lot of what we do as Campus Living Lab is project-based. And I'll go to an example of that in just a little bit. Utilizes campus facilities and is in so doing amplifies the student excitement and motivation. There is no motivating a student more than when you have them realize, hey, I just worked on this with our campus people and we gave them insight they weren't able to have for whatever reason, you know, time. Quite often it's just they don't have the time. Some cases they don't have the background to do it. And they walk away feeling empowered because they made a difference, because they did. And I'll give some examples of that a little bit later here. But and build 21st century employment skills, critical thinking, communication, collaboration, and creativity. So I've focused more on the first three of those, and I want to try to open up more to the creative part of it with my students. But it does really force them to be creative for what they're doing. And the communication part, they have to present this information at the end of every class to the operations department when they're done with the project. And that pressure really does help them focus on communicating better and doing a better job of what they're doing. So with living labs, this part here for me is the most difficult part, because every time I do this, it's a new thing. And so it's not cookie cutter. I can't just write a curriculum and run it, because today's hot water pumping system might be, as a very simple example, a Lake Michigan cooling loop pumping system. And they're the same, but they're different. And that's a more easy one to coincide with. But in other cases, I mean, they're totally different buildings. They're totally, and I'll explain what I meant by that Lake Michigan system in a little bit. But the projects get to be such that they're not always the same thing. They're not always the same piece of equipment. And that takes a lot of time and effort to develop during the course of the semester. And I'll tell you, it's a lot of work, but I always find it rewarding. There's a template for this PBL, problem-based learning and project-based learning, that I will also ask him to post up there. And without documenting what we've learned and the lesson planning, it does make it more difficult next time. And maybe that's where I fall down. I don't do enough of that documentation process. I've been struggling with congestion for the past, ever since Friday. I think I caught something from my family's get together over the holidays. So apparently as the day wears on here, I'm starting to lose my voice a little bit. So we might have to put Larry on next. Energy audit. So here's what I've been doing. I have energy auditing course. I have a measurement and verification class. I have a commissioning class. And those are the three primary classes that I use for campus as a living lab. Last year's was my primary example of doing this, where we took the hot water primary secondary system for the campus, so 340,000 square foot building, and looked at that. We started with the energy auditing and measurement verification course to start to look at the building, doing energy, kind of quasi energy audit, and focusing on, okay, we installed these condensing boilers back in 2014. Why didn't we see the 20% drop in energy consumption anticipated by the increased efficiency of the new boilers? And, you know, in thinking through it going into that semester, I had an aha moment. Well, maybe it was more a moment when my boss slapped me in the face and told me, but it was a situation where it's like, oh yeah, the return water temperatures never got thought about. So we looked at this boiler water system, primary, secondary loop, that had been cobbled together since 1974. So it started out with a smaller building, 1974, got it added on to multiple times over the course of the years. And to where now it was a system that they had gone in and put condensing boilers to replace the 1984 boilers at the time. They were atmospheric fire boilers, and they didn't bother to address any of the temperatures in the system. They just slapped the new boilers in, built a primary loop that actually fed into the original primary loop. So it's like they had two sets of pumping systems on one loop, and it was just so cobbled together. But by us stepping through it as a class, we were able to point out that, hey, one, we did the Energy Star, we did the utility analysis. You are not saving energy that you thought you were going to. That set the basis for understanding the whole process. And the students learned so much by seeing that. And then things start to click through in the course of the semester. And then going into the spring semester, looking at it from a commissioning standpoint, what can we do? So, you know, we thought about different types of tests that we can set up to establish why the system's not functioning the way it is. And I hope to do that actually this semester. It's been a year since we did that study, but this semester we have a commissioning class, and I want to start doing some of those commissioning tests on the system. So by doing that, it really opened up the students' eyes as to, one, what the spaghetti network of piping was in this building. I mean, seeing it on drawings, seeing the simple systems we had in the lab, which to them was incredibly complex, and then seeing the building system was even that much more complex. And stepping through all that really helps them to understand what they're looking at, give them ideas on why it's not functioning correctly. And I'll bet you that all those students who came through that class, when they're working on a hot water system that has condensing boilers, one of the first things they're going to think about is, what are those return water temperatures? And if they're not where they should be, how do I get them down? So it's a really helpful thing for them. And they walked away realizing that they made an impact for our operations to provide them with ideas on how they can modify their systems to start driving towards that 20% energy efficiency they had hoped to have had with the original boiler project. And I'm gonna give one more example, and then I'm gonna shut up and open it up for everybody. But this past fall, what we did is there's a hands-on and I'm not quite sure the right phrase for it. It's not a children's museum, but it's a large museum on the lakefront of Milwaukee that has this Great Lakes water display of all the watersheds and rain. And it has all 5 Great Lakes in it. There's all these different aquariums, freshwater, saltwater, and there's all these other exhibits in this huge facility that the students were able to come in. They took us both through the mechanicals and through all the exhibits, and we start analyzing an energy audit class last fall. Okay, they had all these different pumping systems. This is where they had Lake Michigan water loop going through that was used for cooling the building most of the year. And tied in that, there's all these other pumping loops associated with it. How do they all fit together? So I don't, to be quite honest, think that the facility people actually understood what they had. And so that's quite often common things. I had that happen with a nature center too. They didn't understand their building. So by us coming in, it helps them start understanding their building. With that museum I just talked about, it's called Discovery World. It's a really cool building on the lakefront. We walk through, and one of the things I constantly talk to students about in the energy auditing class is when you're pumping water, there's always a balancing valve because you can't size a valve or a pump to match what's needed for that water system. So you have to have a valve to throttle it back. And if you don't have a valve with a frequency drive, well, that valve better be throttled back some. Frequency drives on it, you should be at 100% open. Otherwise, there's something odd about it. And in looking at the building, right away, one of the students came up to me and said, "Hey, Ted, this system here, the valves closed 80% and the other valves closed 60%. They're fighting the head all the time, and they got variable speed drives on this." Well, he brought that to the operations that was leading us around attention right away. Within a week, the guy came back to me and said, "Hey, Ted, we want to open up 100%. Now we're good." So they're making impact right away. And for a student to realize that his eyes caught that is really valuable. There's just no underscoring, at least in my mind, the importance of this campus as a living lab concept. I mean, I'm taking it, extending it beyond the campus that I'm teaching. I'm going to the community, buildings outside the community. And I just feel that it has lots and lots of benefits. And you can see over the past 15 years, I've been going to hospitals, churches, schools, warehouse distribution centers, and office buildings in the Milwaukee area. And it's just been really eye-opening for the students. I don't do as many now as I used to because my energy auditing class was twice the amount of credits, had twice the amount of time available to me to go and do all this stuff. I don't have that anymore. But anyway, so that's how I'm using campus as a living land. I'm trying to, I got to pull the manual back out and read through it again, but I'm trying to get the pedagogy down better, document it so that when I'm ready to kind of walk away from not doing this anymore and pass it off to somebody else, they can take and run with it because I think the community is going to still want us to be doing this. So, so that's the presentation that I had on it. I didn't want to be talking that long, I guess. I want to open up to everybody else and see what type of thoughts and comments you have. What are you doing back at your colleges? Kristen, you mentioned that you're interested in this concept just from the fact that you feel like you kind of are teaching, and you are. I've seen you.
Thanks.
So what's your angle?
Well, yeah, so Raph and I essentially, well, big part of our job is teaching HVAC mechanics how to work on control systems. And we've talked about this in the past, Ted, how there's just not much emphasis on the systems perspective when they're going through the typical HVAC mechanic training.
Yeah.
And so we get all these mechanics coming to work on a large campus with many complex systems, and they look at things from the individual piece of equipment point of view. And so we spend a lot of time working with the technicians, largely looking at trend data to identify system level issues, as opposed to looking at just the specific equipment, if they get a hot or cold call for a given room, don't just focus on the sensors and actuators in that one room. But from a training perspective, that's easy for us because we have an infinite number of problems to deal with, and it's their job. This is on the job training. It's their job to fix those problems. And I got a little taste of what it would be like back in 2019 when you were at Berkeley Lab, and we did a exercise where we diagnosed some faults in the equipment that was serving the room that we were actually having the conference in. And there was some significant challenges there. Number one, well, I was going to go in there the night before and impose faults. I was going to disconnect some linkages and change some set points to unrealistic values. But I could only do that in the time between when that conference room was last being used and when your group showed up for the room, because I couldn't be affecting other people. I got lucky, and there was actually plenty of things already wrong with the system that I didn't need to impose any faults. And so we had no limitations on things to look at. But also there was a big challenge in the fact that, the larger your institution is, the more rules they're going to have. And because of our safety policies, the students couldn't enter the mechanical room. So I think that would be a big barrier on a lot of campus environments where there's safety and also liability issues with having students being around energized equipment, or even potentially interacting with equipment that would involve a lot of effort to overcome that with your safety folks.
Yeah, so far I've been lucky. Both, and there's never been any incidents. That's the primary one, right? But the other is that they don't necessarily restrict us from what we can do. It's basically, my approach is we don't touch equipment unless somebody's there walking us through it from facilities. So I don't want to be making any changes or having them do anything that involves physically touching the equipment to make a modification. That's not something that we do. So I feel like we've been okay from that perspective, and we've minimized the potential for a hazard. Now, it doesn't mean we're not going to have a trip hazard or something like that. I mean, that's still entirely possible. They have banned us from the roof, so we can't go up there anymore. But that's okay. They took the solar panel array that was up there that we looked at off anyway, so I don't care.
Mm-hmm. Yeah, but I also see that, just in your example of the new heating plant, it's a perfect example that you can learn a lot from once, but then ideally it gets fixed. You identify a bunch of problems and you hope that they are solved, which means that they're not going to be there for the next class. And you have to continue to find new problems to solve every year. And if you're the person responsible for creating a curriculum, I can imagine that would be very challenging.
It is, and sometimes students look at you thinking, how come you're just making this up as you go? Because it's a whole new project. He's got to be. You can't just cookie cutter this stuff. That's what got us into this problem. But one more comment on that project, by the way. I was very disappointed with the design engineer for that project. I'm not sure if it was their fault for not understanding that temperature issue with return water, or if they told operations about it, and my operations is my operations, and just didn't understand what they're saying, or didn't want to understand it. But anyway, anybody else have any feedback on that connection for how you deal with the safety in those rooms, and whether you have restrictions by your operating staff in that area? Steve, Connie?
We've had relative luck with a previous environmental safety and health officer. We ran them through basic protocols and verified insurance. And we have relatively unfettered access to everything on our campus. We also do a lot of community living lab work, and we do a safety assessment prior to that. We have ruled out a few sites where we've had sloped roofs, or we have roofs without parapets, or external ladder access. But we do field trip forms, and we have insurance. And our administration has seen this as absolutely core, that they don't feel they can offer the opportunity without the access. So they've gotten behind it and supported us. But turnover is the killer for us, right? Administrative turnover or ES&H turnover. I have to admit, I'm hesitant to always go back when we have somebody new in the role. If we keep operating per previous agreement, I'm fine. If we go ask for permission again, I'm always concerned that somebody's going to decide it's too risky.
Yeah. Yeah, that's important. It sounds like you've actually taken it a little bit step further than what I've done as far as requesting insurance checks and safety checks on the site that we go to. I do take the step, and I was told that you take the step of filling out the tour or the field trip type forms so that insurance does cover anything that happens. And so I do that. So maybe I am covering it and I don't realize it. So,
We've established $0 vendor relationships with a few governments where we were consultants to them, and then our standing GNL policy insured our students. And so they were then comfortable that we were acting as an energy auditor
yeah.
in that, and that met all of their requirements. So that was one way to get through other bureaucratic organizations' permission to allow us on into and onto spaces.
Which makes sense because with this museum we just went through, I realized that on that last day we're presenting in the fall, that basically if I had to charge them to do what we did, as in my private firm, that would have been a $7,000 to $10,000 project. So, they got a lot of benefit out of that. So,
And just to that, we've scaled up now to where we are actually offering, we have compliance mandates for audits, and our students under supervision of faculty are meeting and recognized as meeting the first tier of those compliance requirements for the audits by the regulator. And that's been a partnership with the policy and regulator. And so now we're going out to underserved community buildings, and we've now scaled that up with another DOE support grant that we're going to do the next level. And then
so can you explain that a little? Is that an insurance requirement you're talking about?
No. So just, I think just we in Seattle and then in Washington State basically have tune-up requirements. They have to take a building through a light energy audit every on a 5, or now it's going to be on an annual cycle.
Gotcha.
And so we've agreed with the regulators that our students overseen by a qualified faculty can go into a building and provide the assessment services that the building still has to do any cure. And so that recognition has now, if somebody's non-compliant and they're a community-based organization or have a hardship in the private sector, the regulators will actually recommend that we go in and offer that service for free. So to what you're saying, we can come in and offer that service where folks can't buy it or don't buy it. And that creates a pipeline of new projects for us.
We had kind of done that through the Better Buildings Challenge here in Milwaukee, where our students actually were paid by the Better Buildings Challenge group here in Milwaukee to conduct audits. So something similar, but I kind of like yours better. Can you send your regulators over who set those performance standards up for the city to make it happen here?
Yeah, well, check. I know that DOE is running a program right now on building performance standards, and I know a ton of cities are part of that development.
Milwaukee's trying to get up and do it, but not always easy to do. So, okay. All right. Anybody else have their twist on what they're doing in the area of campus as a living lab. And Madeline, welcome.
Hello, thank you. I'm a freelance writer and I write a blog for AT Central. So I'm
Okay.
interested in the Institute and I'm preparing an article for Monday's blog.
So you're not going to be helpful in providing input to this discussion then.
Sorry, I am not. I am here to learn. I'm
Right.
not contributing in that way. Hope to take
Yeah.
your information and spread it to a larger audience.
Well, thank you. Connie, are you still there? Do you have anything to add? How are you doing campus as a living lab, or aren't you?
Well, I am do nothing at the scale that you're talking about. I wish we could, but I'm really impressed with y'all. But we basically use our buildings as examples. We have our facilities manager come and give us a tour and talk and all of that kind of stuff. So we get to see the real buildings, but and the real mechanical rooms and the data that they pull off, but we don't really get to do the level y'all are talking about, where you're actually going in and affecting things.
Okay.
So I want to, but
Yeah,
it looks like a lot of work.
it is. It is. And I think there's a way that, if I had another 15 years I was out here, I could probably figure it out, right?
Yeah.
That you can do it so it's not quite as much work. But part of me is like, that might take away some of the fun.
Yeah, well,
I do enjoy this.
I think it would be fun and, as you say, motivating, but as I said at the beginning, we're still developing the program.
Yeah,
I mean, we just don't have the spare energy to do it. But by
right.
the time we get done, I'll probably be tired. So I won't be the one to do it. But I will plant the seeds because it does seem like really good stuff to be able to do that.
Maybe for the long term for me is, when I go back, when I leave full time and just want to teach part time, maybe they'll let me just do that aspect of it. I don't know.
That's an idea because I mean you want to just do the fun part, right? You don't want to have
Right.
to do all the yeah. So maybe I'll do that. I'll plant the seeds and then come back and be the one that makes it grow.
Yeah. My boss is pretty good right now. He might actually be amenable to something like that.
Mhm.
So, um, well, I think you've heard some of the discussion here where it does take a lot of thought process. This museum, for instance, I've been really struggling with how do I get this partner, and they want to do this. It's part of their mission is to educate. So they've opened up their building. They have classroom space and stuff. We can actually come and hold a class there if we want to. The problem is that, all my tools and stuff, all my equipment is physically anchored down in my campus, and I can't
Mhm.
bring a lot of stuff there. So that's an issue. And so I have to wrap my head around how can I make this work long term with this partner who is very willing to let us be there, provides us with free parking and free access. So we're kind of doing that dance right now with that particular setup. But I have people asking me all the time to come on and take a look at stuff. So
Well, and that's something that I think would be part of what I like about what I heard from both of y'all is going out into the community, not just sticking to the campus, but like going
yeah.
to a small public library or I'm thinking of what would be around us, churches. Have you actually done churches?
Yeah,
Yeah.
2, 3, 4.
Yeah.
I mean, through the program, I've done. I don't know. I can't even count how many I've done outside of the program. But
Well, no, but I mean through the program, getting
yeah,
students to go in. Yeah. So I like the idea, and it's going to marinate in my brain for a while, and
yeah.
hopefully become something. Yeah. I
I
keep
know as an
listening to your
instructor.
talks.
What was that?
I said I'll keep listening to your talks, and
Okay.
eventually it'll prompt me to actually do it.
Yeah, as an instructor, I jokingly say, well, that's where the fun is. But the reality is I learn by doing it this way too. I learn much more than if I'm just working in my lab. And, we're human beings. We like to be useful. And that process of learning is part of that being useful. So for me, it's just part of wanting to be engaged in actively doing what I'm doing, not just passively running through a curriculum.
Mm-hmm.
So it does make a difference for me in that perspective. Plus, you get out, you get to meet some really cool people.
Mm-hmm.
It-
No, it sounds all good. We just have to have our feet under us on the main part of the curriculum.
yeah,
No, I have to be confident in myself going out and doing something. You have a business doing this already, right?
yeah.
So we
Doesn't
have
mean I'm confident, but
well, yeah, but we have the problem of having drafted people from other fields to
yeah,
develop our program, and so we don't have the confidence to go out.
right, right. It does make a difference.
Yeah.
So
Yeah, that was a comment I was gonna make as well, is that it does make it more difficult to rotate in adjunct faculty or to scale, that you're truly looking for a practitioner in that case with extensive field experience. And those practitioners with extensive field experience that relish teaching in an uncontrolled live environment are rare specimens.
Yeah. The intersection's very
sadist, were you
small.
gonna say sadist?
Yeah. So,
Yeah.
and so, part of the question is there a way to develop faculty in doing this? It's like, how do we develop ourselves? Not y'all, but for us. How do we develop ourselves to be able to do something like that? And short of going out and actually working, trying to get a company to hire us for a while, I don't know how to do that either. So,
Yeah. The only way I can think of, Connie, right offhand is my adjunct right now. I'm taking him under my wing and trying to drag him into everything I do. So, I got to do a little bit at a time because he's still an adjunct. He's only part-time. He doesn't have time for all this stuff. But that it's a transition plan that I started in motion back 7 years ago with him,
mm,
where when he was in my program before he graduated from the BAS program, I told him, you get some time under your belt, you think about coming back here and teaching.
mhm.
He did. So, it's that process. And again, I guess it takes somebody who's thinking along those lines for this type of thing to happen. But it does take time. It
Yeah.
takes effort. And I'm going to be gradually pulling away from my position, bringing him in. So he's lucky because that's not the way a technical college usually works.
Mhm.
And it's not the way my technical college works. It's the way TED works, but it's not the way MATC works.
Right.
I got to find ways for MATC to accept what I do. And that, it's difficult when they make it difficult to do the right job.
Yeah.
What's best for the students, even though that's what they say they want, what's best for the students, right? So,
Yeah. Well, that's our problem though. It's like it sounds wonderful, but we don't have faculty that have the experience to do it, really. So,
yeah.
Connie, where were you located again?
Raleigh, North Carolina.
Okay, so the one plug I'll make, it's still developing, but the recent DOE recently awarded a set of building training and assessment centers. And there is an industrial assessment center, it looks like out of UNC Charlotte.
Oh,
The industrial assessment centers have learned how to do this in the industrial space pretty well. They are typically running a lab where it's teaching students to go out and offer energy efficiency audits in the industrial centers. And so they're partnering as the building technical assessment or building training and assessment centers to expand that to buildings. But it may be worth looking. So it looks like Fayetteville State just got an award for that. That's going to be starting up in a couple later on this year. And it looks like there's an industrial assessment center at UNC Charlotte. And I know that they're interested in partnering broader strategy to offer this kind of training. So you might be able to find folks that are going through that program or expertise through that program.
Yeah, and the other part of that, and Steve, maybe you kind of covered this, I didn't quite catch it though, is that the IACs, they're looking at more of a regional approach. So they want to bring up the level of understanding of working with technical colleges to implement these type of audits and processes. And so it's something where it used to just be industrial assessment center. They would send out their students to different industry sites and do these audits, which, you know, some of the ones I've been involved with, because there's one at University of Wisconsin, Milwaukee, they would want to study a better way to cut a piece of metal, just because, you know, they know that if you do it at this speed or that speed, you get different energy consumption rates and quality. A little more high end of what we want to do as far as energy audits on our end, right? So these groups, they actually, I've been trying to work with them over the years, and I've just never really quite found the right match of time and abilities or whatever. So they had asked if we could act as one of their satellite sites, and they want to bring other sites in from around the region to MATC, where I would set up curriculum and I would teach them all this stuff, which would have been kind of cool to do. But, you know, this is about this time last year, and I'm sitting there going, I'm crushed with all the work I got. I can't take this on. I'm sorry. So, yeah, they might have some opportunity for you there. If the one by you was thinking like UWM was, of having one site helping to educate other sites, that would be of great benefit, I would think.
Yeah, thank you. I will check that out.
All right. Oh, so Steve, is that the IAC site link you put in there?
Well, that's the link to the expansion of the just awarded IAC collaboration to build out the building training and assessment
Okay.
centers.
Good deal. Well, what else do you guys have on your mind about this area that you want to ask questions? Like, Chris, is anything coming to mind for you or for Raf that you want to ask about it, that maybe we can provide some insight or help on? If not, you know, we're always available. You know how to get a hold of me.
Yeah, I mean, I just reiterate that, you know, I think this is really important. I think there's a lack of educational opportunities for people wanting to get into this field, and it is a pretty big field. I mean, from my perspective, it's in every commercial building, industrial building across the country, across the world, but it seems that there's just not a lot of opportunity to learn. And like I said, all of our technicians either came from other industries and then just randomly got a job with a controls contractor, or they went through HVAC school and they take one class on control systems and they learn the very basics.
If that, right?
Yeah, and then the standard practice of taking a new employee and sending them to vendor specific trainings is also very insufficient in terms of actually learning the systems perspective of HVAC or controls in general. So I think it's wonderful what y'all are doing, and I really appreciate that there is an effort to expand that.
Yeah. Well, and you know, right back at you with if you have any ideas of how we can attract more people into our programs, it would be really helpful, because It's an area that hits all of us. We've been doing Best Center stuff since 2012, I think it is. And I've been involved since 2013, and I have heard the whole time that marketing's a big issue. Well, I developed a sustainable facility operations program when I first came to MITC, and it died because we couldn't get enough people into the program. Then we developed this controls program, and I'm struggling right now trying to bring more people in. And I have a big effort, and I have a NSF grant to do just that. But I'm lucky because I figured out how to do that, and not every college can figure out how to get the resources together to be able to do that. And if there's any way that anybody has input as to how we can find more people to backfill this career, it'd be great, because I haven't hit the magic bullet on that one yet. Not that I want a magic bullet, but a little bit easier way to do it than what I'm doing right now. Spending half my time marketing.
Mhm.
So,
Yeah, I would like to think that there's a lot more younger folks that would be interested in this if
Mhm.
they knew that it was an option.
there's the key.
Like back in 2018, I think, my boss told me that his 12 or 13-year-old son was going to summer camp to learn how to program microcontrollers. I spent 7 years in college learning how to do that, and then find out that, my boss's 13-year-old son is able to do what I was doing for my senior design project in summer camps, because
Oh, wow.
they just have a lot more exposure,
Yeah.
and this is more of a common, these technologies are far more common
Yep.
and understood, but I think that our industry is just kind of invisible
Yeah.
when it comes to making, when you're 18 years old and you have to decide what you're going to do for the rest of your life.
Yeah.
This isn't really on the radar.
And that's why I'm out there constantly, just trying to bring the information, and people say, no, hey, there's a career based on your thermostat on steroids, connected to every thermostat on steroids in your neighborhood, not your street, your neighborhood. You can have. Does that sound like a pretty accurate description of it to you?
Yeah.
And I tell it to grade schoolers, high schoolers, middle schoolers as often as I can, so that it gets their attention. Because it seems, oh, thermostat, that's pretty simple, right?
Right.
Got to have some type of barb on that hook for them. So, all right, well, thank you everybody for attending. You can always just reach out to myself if you have any questions. I'm listed on the website, and have a good night.